Hi, thanks for joining me. We're going to be discussing exponent rules in this video. There are quite a few rules that we're going to go over. I have the rule listed and then I have a quick example to kind of show why the rule works. So let's look at the first one. The product rule says that if you're multiplying two things with the same base, namely a, right? So that's something we can talk about, a base and an exponent. So the base is the large regular size number, and the exponent is the small number in the upper right section right above the base. So base and exponent. So if you're multiplying two things with the same base, you can simply add the exponents together. So notice we have x squared times x to the fourth. They both have x as the base. X squared means x times x. And x to the fourth means x times x times x times x. So x squared, we have two x's multiplied together. X to the fourth, we have four x's multiplied together. But really you can see that that's just multiplying six x's together. So x to the sixth. And you'll see that 2 plus 4 is equal to 6. So that is the product rule. And again, that applies only if the bases are the same. Next, we have a quotient rule. It's very similar to the product rule. Now we have a base on each side of the fraction bar, so one on the top and one on the bottom, and we simply subtract the exponents. And so we know that y to the fifth means y times itself 5 times. So if I write that out in expanded form, I get the y times y times y times y times y. And then in the denominator, I have y cubed. So that will be y times y times y. And what's happening here is since everything is multiplying on top and multiplying on bottom, it's factored. So we can cross out common factors and those divide out to leave ones in their place. So 1y from the top can divide out with 1y in the bottom. And I can keep doing that until I have no y's left in the bottom to cancel out. And you will see that there are two y's left in the numerator and only one's left in the denominator. And so remember, if you have a fraction with a 1 as the denominator, you can just write it without that, right? Anything divided by 1 is itself. So y squared is the answer. And you will see that your exponents were 5 and 3, and if you do 5 minus 3, you get 2. And that's because there are 3 on the bottom to cancel out with 3 on the top, and that only leaves 2 left. Now another part of the quotient rule, and we'll see why this is important later, is that really you can think about subtracting and leaving it where the most were. So this rule really is good to use if the highest number is on the top. So 5 minus 3 is 2. But if I had another one, let's say I had a cubed over a to the fifth. If I use this quotient rule, I notice that the numerator is first, so I would have to do the numerator minus, right, minus the denominator. So 3 minus 5, oh, well that's going to give me a negative exponent. So I'm going to have to figure out what to do with that if I use this rule. But if you think about it in expanded form, to me it makes more sense to do it that way. Okay, so a cubed is a times itself 3 times. A to the fifth is a times itself 5 times. So if you notice, you start canceling out a's. You can see that I can keep canceling until I have no a's left on the top this time. So all those a's that are canceling out, remember it's leaving ones in their place. So now on the top I have 1 times 1 times 1, which is just 1 on the top. And now in the bottom is where I have a's left over. So there were 2 a's left over on the bottom. So wherever the bigger number starts, in this example, the bigger number was in the bottom. So your answer was left in the bottom. In the first example, the one I started with, the bigger exponent was on the top. So the final answer ends up being on the top. Right? So that's another way to look at it. and it will help you avoid negative exponents. And we'll talk about negative exponents again in a minute. The power rule. So this says that if you have one base raised to two exponents, you simply multiply those exponents together. So notice I have z, that's the only base, and that base z is cubed, and then that is cubed. So two exponents are applied to the same base. Let's think about what that means. So z cubed in the parentheses means z times z times z. If I'm cubing that, that means I have to write what's in parentheses 3 times. Well, the parentheses are close together, meaning I'm still multiplying. So if I'm multiplying all those z's together, you can see that I have 9 of them. So this is just the same as z to the 9th. And that's why you can just multiply the two exponents that are applied to the same base. That's the power rule. Now that is good as long as you have the one base and two exponents. Now we have the zero exponent rule. This says that anything raised to the 0 power is always 1. This does not make sense, right? When I first saw this, I was thinking that doesn't even make sense. It just doesn't. But let's see what this really is. A to the 0. Let's think about if I have a squared. Oops. Okay. Let's think about if I have a squared divided by a squared. Let's just see what happens. If I use the quotient rule that I just talked about earlier, I could think about it as subtracting the exponents, right? So that would be a to the 2 minus 2. Well, 2 minus 2 is 0. So a squared divided by a squared is a to the 0. But think about another way, right, to look at this. A squared means a times a. Same thing on the bottom. Remember that I can cancel out a's because they're multiplied by something else. Notice that all of the a's cancel from the top with the bottom. So nothing is left except 1's. So 1 times 1 is 1. On the bottom, 1 times 1 is 1. So that's just 1. So I worked this problem out 2 different ways and got 2 different answers. That means that these answers must be equal to each other. So a power of 0 is really just another way of saying you're dividing something by itself. So if anything raised to the 0 power means that it was originally divided by itself. So it's just 1. So you can either understand the explanation or not. It's there if you're interested, but you need to just know the rule. So anything raised to the 0 power is 1. So let's look at these 2 examples that I have. I'm going to highlight them so it's a little easier to see since I've written all over the place. All right, so here's one and here's the other. They look really similar. I've got a 5x and then a 0 exponent. Notice the difference is parentheses. So really think about what is raised to the 0 power. So in the first example, since everything is in parentheses, that whole set of parentheses is raised to the 0 power. That whole thing. So this is going to just be 1. But in the second example, you can see that there are no parentheses. That means the 0 is only an exponent for what it's directly after. So this is only applied to the x. So that's the part that becomes a 1. So this means 5 times 1. So this answer is 5. So the parentheses make a big difference in your answers. So make sure you pay attention to that. Okay, so as promised, we're talking about negative exponents. And we saw earlier that you could get a negative exponent, or you could think about subtracting in a different way. The negative exponent rule just says that if you have a negative exponent, you can move it to the other side of the fraction and it becomes positive. So if you start with an a to the negative m, it moves to the bottom and becomes an a to the m. If you start with a negative exponent on the bottom, you move it to the top and it becomes a positive exponent. Now, a lot of times students start getting confused with a negative exponent versus a negative in the front, a negative coefficient. This is different than this, right? A negative a to the n is fine. The exponent is positive. You should be used to seeing negative a, right? A negative 2, a negative 6, whatever. A negative in front, right, is different than a negative exponent. Okay, that is a negative in the exponent does not indicate a negative number. Whoops. It indicates the size. So the exponent is telling you the size of the number that you have. If you have a negative exponent and you have a positive like whole number for a, that indicates that you have a very, very small number. So that's what the negative in the exponent indicates. Okay, so really all I want to do here is show you how to change exponents from negative to positive. So in this case, we have y to the negative 3. There's no fraction, so I'm going to make it into 1, put it over 1. Anything with a negative exponent, I know that I can move to the other side of the fraction, and it becomes a positive exponent. So this is going to become 1 over y cubed, and that's it. You're going to be expected to always make your exponents positive. It's kind of like simplifying a fraction. They don't have to tell you to simplify your fraction. Eventually that's just kind of known. Same here. You should never end your answer with a negative exponent. You're almost always expected to make positive exponents only. So here we have a negative exponent, so that's the problem. So to fix the problem and make the exponent positive, we simply move it to the top because it started on the bottom. And so now this will be 3 will stay on the top, and z to the 4th moves to the top. And since that z to the 4th moves to the top, there's nothing left on the bottom. So it'll just be a 1, right? And remember, you don't have to write the 1 underneath. You just leave it 3z to the 4th. All right, power rule. The power rule is kind of like, what did we do earlier? Oh, it's power rule. So we did the power rule earlier. This is the power rule of a product and the power of a quotient. So you can apply the power rule as long as what's in parentheses is a product or a quotient, meaning you have multiplying or dividing only. You cannot apply the power rule over addition and subtraction. So a plus b to the n is not equal to a to the n plus b to the n. That is not the same thing. So do not do that. The same is true for subtraction, right? If you have subtraction or addition in the parentheses, you cannot simply distribute the n to the two things inside the parentheses. That is not okay. So make sure I put it in red here. Do not do that. So the power rule can only be used when you have multiplication and or division only. Okay, so let's look at our examples. In the first example, you see that we have x squared y in the parentheses. That's just multiplication. So it's fine to use the power rule. The power rule means that this 3 goes to each factor inside. So x is a factor and so is y. The y is understood to have a 1 exponent on it already because there's no exponent written. So you're simply going to multiply the exponent outside with the exponent inside. So this will be x to the 6th, 2 times 3, and then y to the 3rd, 1 times 3. And that's it. If you look at the second example, think about how many factors are inside the parentheses. Hopefully you can see that there are 4 factors. There are 2 on top and there are 2 on bottom. So on the top, your factors are 2 and x. A common mistake is that people do not give the 4 exponent to the 2. They only apply it to the variables. They forget to apply it to the coefficient as well. So that's important. On the bottom, your 2 factors are y and z. Since it's all multiplying and dividing, there's no addition or subtraction in the parentheses, you can apply the power rule here. So when you do that, you'll have 2 to the 4th times x to the 4th over y to the 4th z to the 16th. So you simply multiply the exponents that are already in there with the 4 on the outside. You can leave it there. Sometimes the computer or your teacher will expect you to expand out numbers like 2 to the 4th because, it's relatively small. 2 to the 4th is 16. So alternatively, you could write 16 x to the 4th over y to the 4th times z to the 16th. So that may be a better answer. If it was like 2 to the 81st, you wouldn't multiply that out because it's going to be a huge number. But something that's pretty small, generally you go ahead and multiply it out. Okay, rational exponents. We're at the last rule, finally. So this one is showing you that a rational exponent, remember rational is just kind of a word for fraction. So I think rational, fractional, they sound kind of similar, I guess. Notice the exponent on that a is an m over n. It's a fraction. And it says that that's equal to a radical, right? That's the kind of the square root sign. So a rational exponent is really a root in disguise. It's another way to write a square root or a cube root or an nth root in this case. The way I like to remember this is a goes to the ER. This tells you where the numbers go. So the top is the exponent and the bottom is the root. So a goes to the ER. The exponent, the number on top of the fraction, is the exponent. Right? So that's going out here as the exponent. The number on the bottom of the fraction is going to be your root or your index. Okay? It's a lot easier to remember ER than EI. It goes to the ER, so I call it the root. All right, so if you remember that, you will get the rational exponents. A goes to the ER. So let's look at our examples. X to the 3/4 power. So if we know that x is going to the ER, we know that 3 is going to go in the place of the exponent, and 4 is going to go in the place of the root or the index. So the base is always going to be what's under the radical. So I can start by drawing the radical and putting my base under there. The exponent is 3, so I can put the 3, and then the root is 4. So I can put that there. And that would be how I would write that in radical notation. So I'm taking it from rational exponents to radical notation. So let me write that out. So this is rational exponents to radical notation. Okay. So sometimes in your homework, you'll go from rational exponents to radical notation, and sometimes you'll go the opposite way. So if you see the second example, I have it in radical notation, and I want you to now put it in rational exponent form. So that means I want it to look like the base is y goes to the ER. That's what I want. So I need to identify my exponent and my root. So I can see the root, right? It's a little 3. So there's my root. So that's going to be the denominator. But what's my exponent? There's not a number written. But remember, if there's not an exponent written, it's understood to be a 1. As a reminder, if you have a radical and there's no number written there for the index or the root, it's understood to be a 2. So if there's nothing written there, it's understood to be a 2. If there's no exponent written, it's understood to be a 1. So if I'm going to write it in the form y goes to the ER, I'm going to have y to the 1 over 3. So y to the 1/3 power. All right, so last, I'm going to give you 2 examples that are slightly more complicated, and they're going to have us using multiple rules at the same time. So let's look at this first one. The first one, I'm looking for anything with the same base or the coefficients, I'm looking to see if I can reduce those or divide them out. So let's start with a 35 over 5. So 35 and 5 are similar in that they're both numbers, right? So I'm going to see if I can divide those out. And I'll see that they do have a common factor of 5. So 35 divided by 5 is 7. 5 divided by 5 is 1. So that part's done. Next, I'm going to look at the next thing I see, and that's x. So I have an x on top and an x on bottom. Notice that the highest exponent is on the bottom, right? It's at 5. That means my x's, since the highest exponent is on the bottom, will be on the bottom. Okay, if I look at the y's, I have a y to the 7th and a y squared. Notice there are more y's on the top, right? I have 7 y's multiplied by themselves on the top, and I only have 2 on the bottom. So that means more y's will be left on top after I cross out some y's. And then last I have the z's. Notice that there's only 1 on top and bottom. So since it's the same, I can just cross those out. Those cancel out right away and just leave 1's. Okay, so let's look at what I have. I have a 7, right, from the 35 and the 5, and that is on the top. Remember, it's on the top because 35 is larger than 5, so it would be left where the larger number was. In blue, for the x's, I can see that I have 2 x's on the top and 5 x's on the bottom. So once I cross out the 2 x's from the top, that's going to leave 3 x's left on the bottom. 5 minus 2 is 3, and it stays where the most were to begin with. Okay, now I can look at the y's. I have 7 y's on the top and 2 y's on the bottom, right? So 7 y's multiplied together on the top. That will completely cancel out 2 of them from the bottom and leave 5 left on the top. So y to the 5th is left on the top. And again, that's because there are more on top to begin with. And then the z's totally cancel out. Those are just going to be 1. And so that would be it. We would get 7y to the 5th, 7y to the 5th over x cubed. All right, the next one. We have some fraction raised to a negative exponent. So first thing you want to make sure is that the fraction doesn't contain any adding or subtracting. And as long as it doesn't, you're good to use the power rule. No addition or subtraction is happening inside the parentheses, so I can use the power rule. Notice on the top I have 3 factors, so I can use the power rule to give each of the 3 factors, 2x and y, that negative 2 power. I can do the same on the bottom. There are 3 factors on the bottom, so I can give it to the 4, the x, and the y. If I do that, I'm going to get 2 to the negative 2, x to the negative 2, y to the negative 4, over 4 to the negative 2, x to the positive 6, and y to the negative 2. Remember that what I'm doing is I'm multiplying the exponents that are there. So the exponent on the 2 is a 1. The x has an exponent of 1. The y has an exponent of 2, and so forth. Once you use the power rule, next you can move all of your negative exponents. So anything with a negative exponent, I'm going to highlight, and I know that I'm going to be moving that to the other side of the fraction. So anything that was on the top originally moves down. Anything that was on the bottom originally moves up. Anything that does not have a negative exponent stays. So that x to the 6th power is going to stay on the bottom. So do not move it because it's not a problem. You're only moving the problems. So this 2 to the negative 2 is now going to be on the bottom. But it's going to be a 2 to the positive 2. Remember, when you move it, it changes the sign. X to the negative 2 is now going to be on the bottom as an x squared. Y to the negative 4th is now going to be on the bottom as y to the 4th. I've now moved everything from the top, so that's done. 4 to the negative 2 was on the bottom, but now it's going to be on the top with a positive exponent. x to the sixth, since it was not a problem and it had a positive exponent, it stays on the bottom. And then y to the negative 2 has to move because it had a negative exponent, so it now becomes y squared on top. Okay, once I do that, then my next step is just to combine like bases. So 4 squared, I can do that. That's 16, y squared, over 2 squared is 4. Look on the bottom. Do you see that I have an x squared and an x to the sixth? Look at the difference between that and the y's. The y's, I have one on top and one on bottom. So since one is on top and one is on bottom, those are going to be canceling each other out, right? They're undoing each other. But the x's are on the same level. If they're on the same level, that's just multiplying, and that's when you add the exponents. So they're working together to create more x's. Whereas the division, they're working against each other and canceling each other out. So if I do that, let me erase the y squared I wrote here, because I'm going to go ahead and think about what happens with those. The y's, I have y squared on top and y to the fourth on bottom. That means I have 2 more y's on the bottom, right? Again, remember that it looks like this. The 2 y's from the top are canceling with 2 of them from the bottom and only leaving me 2. So I'm subtracting. 4 minus 2 is 2, and I'm leaving it where the most were originally. The x's, they're both on the bottom, so they'll stay there. And I'm just going to add those together. So that means I would have x to the 8th power. And then the last thing I need to do is simplify the 16 over 4. So both of those are divisible by 4. 16 divided by 4 is 4. 4 divided by 4 is 1. So if I do that, I only have 4 left on the top, and y squared times x to the 8th on bottom. If you like your x's first, that's fine. You could write it like this. Either one is great. Now, some people might be looking at that and saying, well, why didn't you just flip the fraction? And so that's a common thing that people do. So if you're interested to see another way to work this out, stick around. If not, that's my last example. So let me come over here and do this one a different way. Okay. If you have a negative exponent outside the parentheses, you can immediately just flip the entire fraction because that negative is applied to the whole fraction. So let me erase those marks and let you see. That negative 2 is applied to everything in the parentheses. So in order to make it positive, I could just flip the entire fraction. So this would be 4x to the negative 3y over 2xy squared. So I did not change the signs on the inside. What I'm changing is the sign of the exponent on the outside. So that is also another way to start this problem. Instead of starting with the power rule, you could start with the negative exponent rule. And since that negative exponent applies to everything in the parentheses, you flip the whole fraction and change the sign of only the exponent on the outside. And now you would apply the power rule. Okay? So once I apply the power rule in this case, let's see what I get. I'm going to get 4 squared, x to the negative 6th, y squared, over 2 squared, x squared, y to the 4th. Okay, now notice what happened here. Since I already flipped the fraction, notice that I have far fewer negatives to move. The last time I worked it out, I had to move 5 of the 6 factors. This time I only have to move 1. And that's because I didn't use the power rule with a negative exponent, right? So that helps. So now I'm only going to have to move the x to the negative 6th. So this is going to be 16 y squared is left on top. And on the bottom, I will have 4 x squared y to the 4th, and then move that x to the 6th to the bottom. Notice now, I'm pretty much at the same place I was here, with the exception of I did the 16 and the 4. But we're at the same place. And so we would divide out the 16 and the 4 and get a 4 on top. You would see there are more y's on the bottom, so you would only have y squared left. And you would see the x's are both on the bottom, so you would add the exponents together. So you would get the same answer either way. So two different ways to kind of approach the problem.